Tuning FreeRTOS Kernel applications means being aware of memory usage across multiple stacks, heap usage, and how task priority is resulting in a share of the CPU. For years I've been dumping some of these metrics out with simple printf statements, but that makes things hard to visualize what's going on. Using the Mongoose web server, I'm going to export these metrics as data via web services, then use the power of Google Charts on a web page to visualize the metrics. Let's take a look. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, Pico 2, robotics, IoT and other fun tech. This is my 3-minute summary video talking about this project. If you have time, why not check out the full video? FreeRTOS can give us stats on heat space, stack usage. Remember, we have one stack per task, task priority and task CPU usage. This can be very useful for understanding behavior and tuning your applications. Traditionally, I've dumped these out using printf into a simple table, but using Mongoose, I can easily drop these into two web services that can be called from a web page. These are really very similar to what I've done in previous videos. In this example on GitHub, all the code is in the web metrics class. The dashboard side of this will use Google Charts and a bit of jQuery. With a few hundred lines of JavaScript, I can take the data from the web service and manage charts across each of those metrics. Though the web service just gives a point in time set of metrics, the JavaScript will store this along with a timestamp in an in-memory data table, therefore allowing us to do time series graphs. For most of these graphs, it's simply a matter of creating views on these data tables by restricting the metrics and sometimes the timestamp to give you the current view. To show CPU usage over time though, by task, we need to be a bit cleverer. That is because the tasks are row-level data within my web service, but I need them to become columns to visualize that data. Therefore, for this graph only, I do some rotation of the data, taking the CPU count and producing a grid of timestamps by task. This is all still a little bit on the rough side, I will agree, and a demo. It does produce some visualizations that have taught me some things about how my demo is running though. It is satisfying to watch that straight line usage of heat space and stack to validate that I don't have memory leaks, to visualize the complex sharing of CPU usage across the tasks.